This visualization shows the Internet's original architecture, the traditional page of 10 blue links collapsing and compressing into a single synthesized node. The era of keyword stuffing and fighting to rank on page 1 of Google is over. If you are a computer science student or a web developer currently structuring your application to capture search engine traffic, you are optimizing for a ghost town. The underlying architecture of the web has flipped. The Internet has moved past a human-first model. It is now LLM-first. Users in the modern web rarely click through a sequence of 10 different websites to piece together information. Instead, they prompt an engine like Perplexity or SearchGPT, which extracts, synthesizes, and delivers a single definitive answer. A ranking on a search results page carries zero value when the primary consumer of your data no longer clicks on links. Surviving this zero-click ecosystem requires a complete architectural shift from search engine optimization to Generative Engine Optimization, or GEO. Traditional SEO was purely behavioral. Structure your site to rank high and extract a human click. Generative Engine Optimization is the inverse. The objective is to be the localized answer itself, securing a direct citation inside the generated text block. When an AI engine processes a complex query, it tokenizes the available web content. It cross-references multiple sources, scanning heavily for factual density rather than narrative length. The engine makes a ruthless binary decision. It either selects your documentation as the ultimate source of truth, or it discards your data entirely. There is no second place. If your web application is not structured specifically for an LLM to digest, the crawler will bypass you, and a competitor's content will be cited instead of yours. In a citation-based internet, losing that single reference bracket effectively deletes your application from the digital record. Fixing this starts at the foundation of your tech stack. The primary engineering flaw in modern web development is a heavy over-reliance on client-side rendering. Developers build complex single-page applications, assuming the user will wait for the browser to render. AI crawlers do not behave like human browsers. The left is the human interface with interactive JavaScript. The right is the raw document object model. Bots don't execute JavaScript, they scan the raw DOM. When the spinner finishes, the human sees data, but the crawler's DOM remains empty because it timed out. If your core data requires an interactive script to render, that page appears completely blank to a large language model. You can have the most optimized lightning-fast React application on the market, but if it relies entirely on client-side rendering, it is invisible in the GEO era. Prioritizing sleek human interactivity at the expense of machine readability guarantees zero citations. To bypass the rendering bottleneck, you have to restructure how your application delivers its data. You must utilize server-side rendering. By generating the HTML on the server before it reaches the browser, you guarantee that your core data is immediately exposed to any crawler that pings your URL. Delivering that data requires strict semantic HTML. Bloated generic div tags tell a machine nothing about the importance of the text inside them. Map content into a strict 3-tiered pyramid of H1, H2, and H3 tags. AI uses this hierarchy to parse context. Watch the fail state. If heading structures are broken, the AI cannot map concepts. It abandons the site and drops the data entirely. Strict semantic HTML now functions as the primary mapping API for AI indexing. Once the macro architecture is fixed, you have to format the microdata itself. Traditional SEO rewarded developers for writing bloated 2,000-word essays, artificially inflating time-on-page metrics while burying the actual answer at the bottom. If you feed padded content to a modern LLM, it will actively discard your data due to low token efficiency. This illustrates the 50-word rule. Isolate the direct, factual answer in the first 50 words. The high-density answer comes first, context comes second. To maximize density, remove standard paragraphs. Output your answers using structured JSON LD data blocks for the machine. Providing clearly defined key value pairs gives the LLM a surgical snippet that is instantly verifiable and ready for extraction without wasting compute power. Token efficiency, rigid brevity, and raw data structure have completely replaced narrative length and user engagement metrics. Zooming out, this structural shift dictates the long-term future of web deployment. Engineering priorities have shifted toward building for machine extraction with the same rigor as human navigation. This diagram shows the new reality. To remain visible, web applications must function as dual pipelines. One path renders the UI for the human. The parallel path provides a clean, highly structured API for AI agents to read. Now, here is your immediate action step. Open a current web project in your portfolio. Audit the codebase and aggressively strip away any client-side JavaScript that is hiding your core data. Verify that your content is explicitly exposed through server-side rendering, and ensure your semantic heading map is flawless. Once the architecture is sound, you can prepare for the next layer of technical implementation, injecting surgical JSON LD data blocks directly into your headers. Surviving the zero-click internet requires discipline. You must abandon human-centric vanity metrics, strip away the interface bloat, and fully surrender to the strict structural demands of the machine.